Today we're going to look at powers. Powers can be used to simplify repeated multiplication. So just like we use multiplication to simplify repeated addition, for example, if I've got 2 plus 2 plus 2 plus 2 plus 2, that's the same as 2 times 5. So we don't have to write all of those 2's, we just write 2 times 5, and that's why we use multiplication and why multiplication exists. We can also simplify repeated multiplication by using this notation, this power notation. So if I use 8 times 8 times 8 times 8 times 8, and I've got 8 multiplied 5 times, that's the same as 8 to the power of 5. That's what this notation means. And the number that has the power raised to it is called the base, and this has a couple of names. It can be called the power, it can be called the index, or it can be called the exponent. Okay, so it just means exactly the same thing. This means that I have multiplied 8 5 times. Powers need to be evaluated before multiplication and division in the order of operations. So in our order of operations hierarchy, we start with brackets, still always look for the brackets, and after the brackets have been evaluated, we look at and look for any exponents that we can evaluate, any powers that we can evaluate. And then we work on multiplication and division, and then addition and subtraction. So here we've got an expression we can evaluate here that has exponents in it, that has powers in it. So here we've got 8 to the power of 2 minus 2 times 3 to the power of 3. So that's how we can say these. We say 8 and then to the power of what the power is. Okay, so this would be 8 to the power of 5 in that example. So 8 to the power of 2 is the same as 8 times 8. 8 times 8 is 64. Here I can evaluate this power as well, 3 to the power of 3. 3 to the power of 3 is the same as 3 times 3 again. So 3 times 3 is 9, times 3 is 27. So 3 to the power of 3 is 27. So now I don't have any more powers. I can evaluate any multiplication. I see multiplication here. 2 times 27 is 54. And then I can evaluate the subtraction here. 64 subtract 54 is 10. So we've got a couple of examples here. A few examples. So simplifying, expanding and evaluating two expressions. So to simplify our rather bulky expression here, make it a bit more simpler, more compact, using our power notation, which is going to be really helpful in the future, we can have a look at, it's a bit muddled up, there's 2's and 3's everywhere. To make it easier to see what we can do, because of the associative law, we can multiply in any order when we have a multiplication. So let's move our 2's to the front. So 2 times 2, and then times 3 times 3 times 3 times 3. So we've still got our 4 3's and still got our 2 2's there. So 2 times 2 is the same as 2 to the power of 2, and 3 times 3 times 3 times 3 is the same as 3 to the power of 4. So that's it in a simplified way. 2 to the power of 2 times 3 to the power of 4. If we're looking to expand first and then evaluate, to expand this out we need to convert it from the power notation to our expanded multiplication notation. So here 2 to the power of 4 is the same as 2 times 2 times 2 times 2. I've multiplied it 4 times, there are 4 2's that I'm multiplying. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So our evaluation there is 16, our value that we've obtained. Lastly, if we're going to expand and evaluate 2 to the power of 3 times 5 to the power of 2, 2 to the power of 3 is the same as 2 times 2 times 2, and 5 to the power of 2 is the same as 5 times 5, so I've multiplied those two together. 2 times 2 is 4, times 2 is 8, so I've done that first, done the 8. 2 to the power of 3, evaluated that first, and then evaluating 5 to the power of 2, 5 times 5, that's 25. 8 lots of 25, or 8 times 25, is 200. So our evaluation of 2 to the power of 3 times 5 to the power of 2 is 200.